Welcome to Vantage Technology webinar. Today we have another session on the Databricks. In this session, we are going to discuss how you can ingest data into the Databricks through the two different methods, create table as CTAS and copy into. So before starting this session, let me introduce myself. My name is Rajneesh Kumar. I am the CTO of Vantage Technology. So let's jump on the today's topic, data ingestion with CTAS and copy into. So basically, is the Databricks offer the two SQL based approaches. First is create table as they generally call as a CTAS, and second one is copy into. So CTAS basically used for the single load whenever you are loading to the uh, first time, and then you create the table, and then in one load, one command you can create the table and you load the whole data into the table. Into the table is that where the we generally use CTS. Second method is copy into. Copy into basically when we use incremental node whenever we adding the data keep continuously. There we can use this copy into. This is a very flexible whenever you are working on the small set of data and keep incrementing those data. Then we use this command is as a copy into. If it's a large data, then there is another command, another way, another process you can use it, which we discuss in the different session. But this right now there's a two different SQL based we can use it as data ingestion. One is CTS, another one is copy into. So for two different use cases. So let's what is create best for is let's look into the what is CTS is best for is. So CTS best for is first one time load. Whenever you are using a CTS, it is best for the one time load. Whenever you are initial data load, you want to in one of the tasks where the source data is a static, then you can use the CTS. Second is ad hoc analysis and exploration. So quickly materializing a data set for immutable querying without the robust pipeline setup. There you can use it this analysis, quick analysis. There we can use it this kind of data ingestion. And third one is transforming data during the ingestion is. So select query can include the transformation before the data save into the table with. So we transform the data and then save into directly into the table. This is a use case perfect. We can use this use cases. So now let's look into the copy into best for is where we can use it. So first is repeatable SQL ingestion. So basically, whenever data is keep coming, what I just explained is the command is important, like meaning it can run multiple times safely and will be ingested only one data without replicating the same data into the data load. There you can use it copy into. Second is a small to medium data volume. So if data is a small and medium, then we can use it this data ingestion process. So if it is a larger data set, data volume, then during that time we can use the autoloader. This is recommended by the autoloader. And third one is handling the various file format. So it is you can handle the different file format, like if it's a file is CSV or Parquet file or Avro, any of those kind of file format is there. Then during that time you can use the handling various file format. This is best for the this use cases. So copy to into this three format. So let's jump on the another demo of the Databricks. In this demo, we are going to cover data ingestion with the create table as and copy into, which is called as a CTS. So in this demo, we are going to cover use the CTS statement with the read file to ingest Parquet file and copy into incremental load Parquet file from the cloud object. So let's jump and just see how this thing will work within a Databricks is. So I already configured this system which we can read the data from one of the location. So let's explore the how the system is configured, and then we can go through the all command how you can ingest data through the this command copy into and and an incremental Paraquat file is. So here this is your system where the all file is. I This is a file which I'm going to read. uh, it is stored the DB Academy Commerce. It is part of the volume. This is mapped over here from the S3 bucket, and raw, it is part of the raw folder. So this is a file we are going to read, user historical. And you can see like there is a couple of files there in the Paraket file. So I just expand this one so that you can see the extension of this file is. So this is Paraket file. So we are going to read this file, and we are going to copy this file into this location. It is part of the volume. So it is going to the CSV, will go to the CSV demo file, JSON will go to the JSON, and XML go to the XML demo file. So this is it's all environment is set up for you, so you can work on this demo. So let's see how we can ingest data into the disk catalog. So let's see in which catalog is schema, and what is the name of the catalog and any schema name. So just you can find this way. Select the catalog and the current schema. We are in the DB Academy lab user. The same thing is I showed over here. Lab user, a part of the DB Academy. And now we are explore the data source file is where we are going to read this file is. Just I showed to is part of the raw and user historical. So we can list out all folder and file from this folder. So you can see like all file is over listed over here. I showed over here what are the different files over here at this location raw. So you can go through the command prompt as well as you can directly browse into the Databricks. There is a two way you can find and you can validate those things. So it is part of the user historical, and the same information coming over here. So you can find this way, and you see like it is a Paraket file. Now we are selecting what are the different information is within this Paraket file is. So these are the information is within this Paraket file. You can see like user ID, user first touch timestamp, and then email ID is there. So three column is stored as a Paraket file. Now we are ingesting this data with the CTAS and the read file is. So create table as, which is called the CTAS, a statement used to create the populate table using the result of the queries. So let's see is how we can do this thing. So here, this is a command. Let me explain what is this command is. Basically, is we are selecting read files and add at this location, and it is looking for the format is Paraket file. That's how we are specifying is it is only read Paraket file, not any other file is. So if you run, it will pull all information from this folder, which is saved as a Paraket file is. So this information is pulled from there. So user timestamp, user ID, email, and requested information, requested data. So these are the information it is coming. So these are the blank is coming, null is coming. So let's create the table historical user branch CTS RF table we are creating from this file is. So what is happening over here is first we are dropping any table if it exists with this name. This is a standard practice if you are working on any of the environment. So make sure that this file is whenever you are working on the clean data, not like anything is already there. So that's why we execute every time is this any table is exist with this name, drop it, and then we are creating the new table with this name, and then selecting from this Paraket file with the Paraket file location is at this is a path of the Paraket file, and then we are selecting, and then after once create this table, and we are selecting so that we can show like it is being inserted into that table. It is the table is being created and data is being inserted. So let's run what other things is coming. And it is only limit 10, so it will select only 10 row. So you see like a 1 to 10 row is coming. Some of them has an email and some don't have the email, and some of them are null field, and here is null field at this location, requested data. So that's how, so it is confirmed that your table is being created with this name, and which is inserted this data from this location. So this is ingested data from the file and the Parquet file, and then create the table. Now we are going to describe this table. Now you can see like what are the different metadata information for this table is user ID is string, where the catalog name is DB Academy, and then database is lab user. This is a database. Table name is name of the what we put in the name, historical user bronze CTAS _f, and then when it's created, last access unknown. So this all information, metadata information is coming for this table as soon as you describe this table is. So it's successfully created with all information. You can scroll down what are the thing is being created. You can see the location of this is a map, is a volume. That's where it is location. Provider delta. Owner is this user is owner. So is managed location true? It means yes. So and you can expand this one. You can find the all properties related with this table is you can see as a JSON kind of JSON object is. You can see like what are the all information coming over here. So now difference between the managed versus external table in Databricks is Databricks manage both the data and metadata. Data is stored within a Databricks managed stored. Dropping the table also delete the data. Recommended for the creating new table. That's how whenever you are managing through the Databricks. External table, couple of restriction is that Databricks only manage the table metadata. Dropping the table does not delete the data. So whenever you are working on the external table, that's a thing is whenever you're dropping that table, it will not delete the data if your external table is there. External, so support by multiple format, including the data lake, and idea for sharing data across the platform or using existing external. So these are the pros and cons for the managing within a Databricks and outside the Databricks is. Now we can also do through the Python. The same command you can do through the Python too. So this is the command which you can execute. Is the same way like you are defining the Parquet file. It's reading and it is defining the what kind of format you are looking for in that folder, this folder. So it is read that file. Now in the second command, it is writing, and basically is overwriting is anything is there. So it will overwrite and then create those new table at this location. So the DA schema name, the schema name is DB lab user. That's DB Academy. That is a schema, and then DB Academy and lab user is a schema basically is, and it is part of the DB Academy. So save as table. This is a command, and now we once it's created table and save into the table, we can see we can display this information over here. So let's run this command and let's see what other things is being created. Now you see is almost the same information is coming, except the like a name of the table change because we are reading through the through the Python. That's why we change the name over here. And this is historical user branch Python. So this is a new table we created for the specific for Python, so that we make sure that the two different tables are not competing to each other. So that's we created that so that we can show the both data is coming almost the same, exact the same. So now we can look into the another command is incremental data ingestion through the copy into. This is a whenever the data is keep coming in within your table, so that you can use the copy into, so that you can add those data, append the data on top of the existing data is. So that's where we can use this copy into is. So we can look into the couple of options. First, whatever the schema is defined, it is not matched with what is coming, then it will throw error. So how we can rectify that error, that also we are going to walk through is. So now let's see, we are creating a new table. This is if any table is exists, then it will drop and then create the new table. And then we define the copy into. This command is create table and then copy into, which is dumping data from the Parquet file into this table is. That this command is doing. And then basically what is happening is there is a mismatch of the schema, and then you will get there because the Parquet file has a more field, and then whatever you define the schema over here, it is a less field over here. So that's why you will get the error. But there is another command we will walk through how you can rectify if that kind of error is coming and you're expecting the more column, or you don't know the number of column how many is there is coming. So just see is